Test your code. I'm talking today about how to test and what to test and when to test when you're writing code. Music on the show is from artist Quintas Moreira. Okay, today, 3 little points about what's been going on in my personal life, things that relate to this episode and everything that I'm trying to convey here. The first one is that lately I've been really trying to unravel a lot of old code and create some new code that replaces everything, and it's really been fun to write solid, tested code again and to really sort of put my creativity into it. That's another thing about coding and testing, is that not everything has to be a certain way. Not everything, there's so many solutions to everything. You can put in your own little spin on everything. You can test everything differently. You can use different tools. You can use no tools if you want. You just do whatever you feel like it. Now, don't get crazy and try and make a little bit of consistency. Otherwise, people will have difficulty understanding and changing what you write. But it can just be fun to write what you believe is sort of your spin on things. So that's one thing that's been really going great. And then the second thing is that sometimes it's really hard for other people to learn what you're trying to teach them. And I think this relates to my most recent episode of my other podcast called Zero Grok. Go to your favorite podcast player and search for Zero Grok and subscribe to that and check it out. You don't want to force people to learn something. You can try your best. I mean, obviously, if you're a real public school teacher or something, it's your job. You got to do it. But if you don't get that response, that intake of what you're trying to teach to people, then don't force it. You can put out what you have. You can put out what you know, and just that's the best you can do. So just stick to that. And if you don't get the reception, if you don't get the conversion, so to speak, so if you're trying to say convert your team to doing something different process-wise or just thinking-wise, don't force it. Just let it be. Maybe try it again later. And the third thing is the old acronym KISS, but I'm going to put another spin on it that I heard recently, which is keep it super simple. Now look at everything that you're doing, and maybe things that you're writing down, things that you're saying, code that you're writing, whatever. Just try and keep it simple. Maybe you write a paragraph, but really the real killer part of that is only one sentence. So just cut the rest out. People don't have endless time. There's content everywhere. They don't need to read what you have. They don't need to listen to what you have. They don't need to watch what you have. There's so many other options. So cut out the cruft and just get to the point. Let's start with a tip today again, like usual. What if you're unsure exactly what you're building? So you have a task in front of you that you understand the concept sort of at a high level, but maybe you don't know exactly how everything's going to be laid out and exactly what you're changing, exactly what you're adding. Then don't do TDD, don't do test-driven development. Write something that works, that you know that at least it's hooked up together, and then start testing it. Just wait until you're at least partially done with something, and make sure it works by testing it after. So that leads us into the topic for today, which is testing, like I said up front. I'm going to go over a little bit of what I think about when I think about testing. Obviously, there's some things that maybe I leave out because either I haven't done them in a while or they're not relevant to me at the current point in time, but these are kind of the main things that I think about. The first thing is the testing pyramid. I know everybody, or at least a lot of people, know about this, especially when you're coming from a quality mindset or you're have been in enterprise software for a long time, you know what the testing pyramid is. A little shout out to one of my coworkers who likely coined the term, if not at the same time as someone else, but coined the term, the testing pyramid, and the concept. So, all right. The first, well, if you look at a pyramid, you got the smallest point at the top, and then each layer, as you cut down, they get bigger and bigger and bigger. So what you want to do is you want to have your base be the most of your testing, and less as you work your way up. So the base is going to be your unit testing. Your unit testing is going to be all the things that catch all kind of the input-output bugs and all the edge cases for every little piece of code, every method, every function, every class. So those will be super quick because you don't want to hook anything into those. You want them to be tested by themselves as units. Usually those only take on the order of maybe tens of milliseconds to run. So if you're doing this appropriately, you're gathering a lot of these tests over time. If you have a big enough code base, we're talking thousands of unit tests, but they run in milliseconds and you can run them in parallel. So they don't take more than just a few seconds to run them all. The next level up is component testing. So here you're taking those units and you're plugging them together and you're testing them together. Again, this is very similar to unit testing where you don't want any external dependencies hooked in. You don't want anything that's too big, that's going to take too long. Basically, you're just doing the exact same thing in unit tests, but you're putting two or more blocks together. But everything else is still really compartmentalized. You can run them in parallel. You can run them very fast. Again, seconds. The third layer, again, we're getting smaller and smaller. Third layer is integration or contract testing. Depending on your terminology, this may not be what you're thinking about, but the way I look at it is integration testing is testing the integrations. And that's the same as a contract. So a contract saying that you have an integration from one component or one area into another. All you want to do is make sure that those things hook up correctly, which is a contract. These also should be fairly short, but depending on how your system's designed and exactly what it's doing, you may have to stand some things up. You know, if you're using Spring or something, you stand up the container and you run those. But again, these are fewer and fewer. Hopefully you won't have to do that. So we're talking seconds. Definitely under a minute. Now, the reason I'm concerned about time so much is that when you're trying to make change, you don't want to have to wait a lot. So the whole idea around CI/CD is that you want to get your changes out as fast as you can so you can see the result and you can make really small changes. So if you want to, say you wanted to add a feature that's fairly big, you don't want to necessarily take that entire thing and shove it out there and then maybe a very small part of it or the first part of it breaks or is something you messed up somewhere. Then you got to go find where that was. And it just gets complicated when there's a lot of code that's added. So you want to make those small incremental changes. And you won't want to make small incremental changes if it takes 10, 20, 30 minutes, half a day for your change to get out there. So you want to make these as small and as quick as possible. Now, to give a background, this whole testing pyramid thing is something I picked up, years ago. And it's not always, it's pretty much never implemented correctly. Anywhere that I've seen, there's always this goal to go, and that's what you want to do, is you want to shoot for a goal. But, good is good enough usually. Perfect there's a lot of things you could talk about here. But basically you just want to strive for this goal, and if you're happy with the result, then go with it. All right. Enough of that. Back to what we're talking about, the pyramid. After you've done your integration or contract testing, you want to do the integrated testing. Now, you could probably come up with another name that's a little bit more different than integration, but I like integrated because you're describing what's going on here. And you're saying, I want these things to actually be working together. So you're actually, instead of just testing the touch points, instead of just testing the contract, you're actually testing the pieces themselves talking together and making sure, say, you put in this object at one end, this other object comes out the other side. But it's not the entire system. It's just one piece or pieces together. And again, the smaller piece of the pyramid, getting close to the top, so there shouldn't be very many of these. And this is mostly because these integrated pieces are so big. So you shouldn't have a lot of big integrated pieces to test. Finally, the top of the pyramid, end-to-end or system testing. This is when you are testing the entire product, the entire system, the entire piece of software together. Now, this is the top of the pyramid, so you only want maybe a handful of these, and these could take minutes overall, which is fine. Right now, in my current situation, I have a product that it lives on different environments, and we test just nightly these system end-to-end tests. They take hours actually, but it's fine because it's overnight, and we're just looking for indications that something broke in the last few changes, and it works great. I mean, we're making sure that basically the situations that are most important to our product are working correctly. And that's what we want. You could obviously do this as part of the build. It's going to make your build slower, but it may not give you the feedback as quickly as you want. You got to kind of figure out that balance. All right, testing pyramid. Check. Next, test-driven development. So this is something that I've toyed with, but not really implemented that well in the past, because it takes a lot of discipline and it takes a lot of very well-defined changes. And I think it works best for bugs. So for an example, if I want to go in and say that I'm adding a new piece of logic to an existing existing page, existing API, something like that, you're adding a new piece of logic there. You may not know exactly what's going on with that new piece. So strict test-driven development would be, I know what's going to happen, so I'm writing a test to exactly what's going to happen, and then when that happens, or when I run the test, it fails, and then I go in to the production code and I write something to fulfill that test, and then that test passes, and then you move on to the next iteration, the next change that you want to make. Usually what happens is that you're able to break it up into small enough pieces to say that, I want it to do this. And you test it and you write it and it passes. And then you say, I also want it to do this. But I don't really see that working in real life, because you want to make your bits and pieces of code live by themselves and only do one thing. So I don't know, it doesn't really make a lot of sense to do this TDD approach. The TDD approach that I think is most common is it's kind of a back and forth situation where you may write some code and then you write a test, and then you may go back and change it a little bit, refactor it, and then that causes the test to fail. Then you go back and write the test. So I don't really know if I'd call it TDD, but if you are in a situation where you know exactly what's going to change, you can write a test before, and then you get the feedback when you finish the code. And I think this works best for something like JavaScript, a non-compiled language where you can set it up to run your tests whenever you make a change, whenever you hit save, because it doesn't take any time to compile it, or it takes very little time to transpile whatever situation you're in, and you know right away if you broke something or if you fixed something. Whereas usually with compiled languages like Java, it takes a bit of overhead to run your tests and to run all of them. So it doesn't really make sense to code a little bit and then just as you hit save or it auto saves, it just runs the tests. But maybe that's something that I should look into. The next thing, and TDD, the thing I brought up earlier, which is it works well for bugs, is that if you know a bug exists that you've found in production, you can write a test that exercises that bug and that fails because the bug is there. And then you can go write the change that fixes it and then run the test and it passes. That's the way I see TDD working the best that I've experienced. So if you have any other experience for writing TDD that worked a lot better and you can describe it, to me, that'd be great. Yeah, Discode podcast on Twitter. Next up, test coverage. So this will be a short one, and I think a lot of people have sort of the wrong idea about test coverage, or some people do. It depends on, I think it kind of depends on how long you've been doing it. But it doesn't catch, it's not a one size fits all solution. It doesn't just say that you hit 100% test coverage, you're done. No, that's not how it is. But it's a good indicator on if you tested what you wanted to test and what you meant to test. And what I mean by that is that if you see the coverage report and you look at it and you say, oh, every single piece of this code is tested. Okay, I've written tests that exercise everything that I meant to. However, it doesn't necessarily mean you hit all the cases that you wanted to hit. So this dovetails into something that I was planning on talking about later, but because they're so closely related, I'm just going to go right into it, which is mutation testing. Now, mutation testing is a concept where the tool, I'm not sure exactly how this works. I suppose it has something to do with just inspecting the code and adjusting it accordingly. But basically the tool changes, flip-flops some of your logic and some of the situations and takes things out. So one example is if you have a comparison in your code, it swaps it to the opposite of the comparison. So if you're saying greater than, then it changes it to less than or equal. And then it checks to see if your tests that exercise that code fail. They should fail because it's opposite of what you expect. So basically, if it doesn't fail, it means your test is not good enough or you're not testing that particular spot. So they call them mutations. And if you were able to kill the mutation with your test, then you're good. But if they survived, then you need to improve your tests. And this corresponds with unit testing, I think mostly. But again, this also corresponds with test coverage because it explains that you have coverage, but maybe your test coverage is not so good. You may be actually covering it, but you're not doing as good a job as you could. Hope that makes sense. Check out PyTest. I'm not sure exactly how to pronounce it. It's for Java, PITEST. And I can't remember what the tool is for JavaScript. But anyway, that's the best one that I've come across, and it's for Java. It's fairly easy to implement into Maven or Gradle builds. And it's an open source tool. And it's real easy to use once you get it running. And you can have it fail the build if you want to, if there are any mutations or a certain threshold or anything like that. So it's great. Next up, dependency injection. Oh, wait, dependency injection isn't testing? Well, it really is, because the only way, a lot of times, to get your tests running in that really small unit or component level is to be able to inject your own dependencies in there. So if you have something that's more concrete and you don't really want to put one of those concrete objects in there because you're not testing that object, you're testing the code around it, then you need dependency injection. And basically what that means is that, like I said, you're able to inject whatever dependency you want in place of whatever it needs. So if it needs a certain interface described in a class or an interface that you don't want to provide it, you can just give it a fake one and say, when this fake one is exercised, do this. So, and this is another dovetailing situation into mocking. So if you're injecting a mock, and then you can say that when this method is fired, then return this value without actually doing any execution. So this is really helpful when you have a lot of dependencies and you want to write unit tests. So you can just say, whenever this fake object that I've replaced the real object with is fired, then just give me this return value or throw this exception. You can exercise situations from that code, but not of that code. Yeah. But there's also other ways to do the same thing, which is, instead of using mocking, actually, you can pass in functions. So if you're thinking more functionally, Now, this is all coming from a Java perspective. So if you're thinking more functionally, then you can just pass in functions. And so if your original function is meant to do something concrete, you can just pass in a function that does nothing, or that spits out a static value every single time. So that's one way to do it. But there's also Mockito, and then lesser desired PowerMock. PowerMock does a lot of things you shouldn't be doing. So don't use PowerMock unless you really have a good use case for it. And lastly, something that I've just picked up recently and I don't quite understand fully is property-based testing, especially coming from my perspective, which is Java. I know that there are some good tooling for some languages. I'm not positive about Java yet, although I think I heard of one recently. So I'll have to investigate some more. And before I talk anything more about that, I want to implement it myself and try it out. So I'm just going to say it exists. It sounds great. It sounds like something you can use to do really, really great coverage, really great testing to test a lot of scenarios, but not have to write so many tests, basically. I'll leave it at that for now. And that's my look at testing, at least from a development standpoint, and something where you want to think about your code with testing. There's a whole other area around performance testing, non-functional, all those non-functional areas. There's manual testing, there's exploratory. I'm not going to touch any of that for now. We got to keep it sort of dialed in. Otherwise, it could go on for hours. I could go on for hours. Anybody could go on for hours. Moving on. My ongoing saga, I'll talk about that a little bit, of creating a course. I had sort of one of those dips recently in the last couple of weeks where I'm like, oh man, it's a lot harder than I thought it was going to be, right? That's the way things are, especially when they're new, you're learning, and they're worth doing. I picked up in the past, this is something that I did over the weekend. I started over the weekend. So I think I've mentioned him before, is John Lee Dumas. He does Entrepreneur on Fire, and he does a lot of other products. So he's one of those kind of entrepreneurial online success stories, I guess, where he's found a lot of ways to create value for people and to sell, to sort of make a living. Well, not sort of. He does very well. Anyway, I picked up his Freedom Journal sometime back. I think I got it for free or for very cheaply in one of his deals. And basically it's a way to, what's the word he uses? It's like I can't remember the word. Anyway, it's something that sort of keeps you in check. It forces you to keep going and to stay on track. But you do all this stuff up front, which is define what you're trying to do, define what your goals are, and keep on that track. And it's doing a great job so far. It's just a matter of making sure I do the journaling every morning and evening. Sometimes I forget, not very often, and then sometimes it's hard to come up with all the things that he's asking for in the journal. But it's going really well so far. I've created a new lead magnet on a new area of my expertise, and that seems to be going pretty well so far. And I've also picked up doing LinkedIn articles to attract an audience and to find an audience, and it's worked fairly well. I need to keep doing it. I think I had a really big bump today, so that was really nice to see so much reaction and feedback from the article. It was I won't say that it was easy and it was something anyone could have done, but it was not as, I didn't take a whole ton of time doing a lot of research, doing a lot of crafting, doing a lot of making it look pretty. Basically wrote it in about an hour or two, put it up on LinkedIn, and because LinkedIn likes to push its own articles, its own platform stuff, you get a lot of play for an article that's written on their platform. Basically what I'm doing is taking that same article and putting it on my blog And so it doesn't only live there. I don't want to rely on LinkedIn for my content, for one thing, but I also don't want to rely on them for traffic either. Anyway, got good traction there, and I need to write more. I'm going to focus on something a little bit more in depth, more concrete. This was a top 5 list of anti-patterns in enterprise software that I've noticed over the years. And I want to dive into more deeply into something similar, but maybe something more actionable by people. I want something that will give people that sort of initial reaction, initial buzz, initial feel, but also give them something that they can just take and apply it right away. Like concrete, say this for this, examples. And I say, oh, here's the way that I test this, or here's the way that I write this, or here's the way I think about this. And you can take those examples and apply them right away. So that's what I'm going to try on next for writing an article on LinkedIn. I sort of touched on my blog already. It's taken a backseat a little bit, but I'm going to, again, use the article content and put that in my blog. It's just kind of a pain because I have to retranscribe, I have to take it out, copy and paste pieces, and it doesn't translate over exactly. And then the other thing I have to do with my blog, if I want to get some more traffic, is somehow come up with an RSS feed that comes out of it. And Sanity with Sapper doesn't have that built in. I have to come up with an RSS, I think, plugin is what Sanity needs. I seem to be the only person in the world using Sanity with Sapper, so kind of do-it-yourself situation here. And then finally, podcasting. Can't break the chain, so I'm trying to do my best here, but I really need to focus on other things. It's just really nice to have this as sort of an outlet and an ability to exercise my thoughts and share what I know and practice that. So that's what I'm using it as. I'm barely making the schedule that I set out for myself, but I got to keep at it. Now on to kits, and I've added a couple things, like one thing to each, coder and cooking, and I just want to describe what I've added. For coder, I was going to add a kids one. I still haven't added a kids kit. It's been a busy week. So for the coder kit, I added this employee, this senior, I think he's a manager, he might be a tech lead anyway, at Groupon. His name's Carlos. I'll put a link into the show notes after this and to his repo. Or actually, you can just go to kit.com/JeffreyFate. It's on there. So instead of show notes, go there. I probably won't update the show notes. So he has a repo where he has modularize and simplify his code bases using a few different techniques. And one of the ones that I picked up that was fairly easy to implement is the way he tests, well, not just tests things, but defines things. So instead of you're thinking about dependencies you pass into a class, and a lot of times they're various types of objects, whether they're coming from a Spring Java background, whether they're a service, a repository, a controller, those things. Instead of doing that, what he's mostly doing, obviously this can't be 100%, but he's mostly doing is passing functions in. So you write your code in functions, and then you can pass in function definitions, really, is what it is, in Java land. And you don't have to create a mock for something. You can just pass in a function definition. So instead of, as you're talking about a Java Lambda, so you have let's say you have a consumer, I'd say supplier. Supplier is easier to describe. So you have a supplier that starts with nothing. It takes nothing in and produces something. So you're just creating something that gets passed on and is used. A good example is, from my recent perspective, is creating a date time that represents now. You can easily substitute that for some other date time that's not now, that's in the future or something specific. So In this case, what you can do when you're testing it is you can say that supplier produces null if you wanted to test the null case. So you can just put in that lambda expression that says blank to null or blank to datetime.now or blank to whatever. So you don't have to continuously make these mocks and then say when this mock does this, then do that. You can just write it in one line lambdas. Makes it so much simpler, not so much boilerplate, but it also makes it easier to understand and forces you to be more functional and compartmentalized and make it a lot simpler and smaller. That was a long description, but if you just check out his repo and look around his blog about his presentation on this and things like that, it's fairly easy to understand, although it takes a little bit of questioning, I think, and a little bit of investigation yourself to really grasp it. So it's fairly different than what most people have done. And the second thing, cooking, that I've added to my kit, which is a splatter screen. I usually cook meat. Well, yeah, pretty much all the meals I cook have meat in them. And when you're cooking meat on the stove in a pan, you're using some sort of oil, and you're obviously cooking it hot, or a lot of times you're cooking it fairly hot. And when that happens, you get splatter. I mean, it's all over my stove. And I got sick of cleaning it up every single time, and I got sick of, getting splattered on my hands and those kinds of things. So you get the splatter screen down and you're good to go. Dishwasher safe, easy. So it's on there, kit.com/Jeffrey Fate. Check it out. And as always, the show notes are discode.dev/ the episode number, which in this case is 004.md. Check those out. I'd love to hear your feedback, so hit me up on Twitter at Discode Podcast, or my personal Twitter, which is Jeffrey D. Fate. And I hope this was helpful, and I hope this was informative, or at least reiterates your thoughts about testing. Let me know what I missed. Let me know where I was wrong. And I hope to hear from you, and I will talk to you guys next week for another episode of Discode.